Hey guys, welcome to a new tutorial about Drive, the car simulation for Cinema 4D. We have been asked to make a basic tutorial, so this is a Drive Quickstart tutorial. Here we have a Mercedes-Benz E-Class model that I'm going to set up to use with Drive. First, I group all these parts under a null object and rename it to the car's name. Next is to check if it's standing on the zero plane. The model should match the real dimensions. Otherwise, the physical simulation won't produce realistic results. The values of this object look quite good. Next is to align the model to the direction of the positive z-axis. Now the car is ready. It stands on the ground and directs to the positive z-axis. The next step is to isolate the wheels from the body. This is a quite inconvenient work, especially if you have a lot of cars to work on. Fortunately, there is a tool that you can download from our website for free. The car rig helper is a simple one-click tool. Just select the group object and choose Car Rig Helper from the plugins menu. And voila, you'll get all the required components. The body and the four wheels clearly separated in different groups. By the way, the Car Rig Helper also works on car models merged to one polygon object. So now we can create a simulation object. In the simulation object, we create a vehicle object. The vehicle object provides all the basic components, like the body and the wheels, as container objects that have to be adjusted to our Mercedes and be filled with the model objects. This task can also be automated. Therefore, we open the Geometry tab and move our model objects to the list field. Clicking on Create Setup adjusts the container objects to the vehicle object to our model and fetches all the geometry. Okay, the car is now ready to drive. Let's make the first test. There are two possibilities to make a car drive. We can create a command object that tells the car to accelerate, or we can create a route object giving the drive line. Let's start with a route. A route is a simple spline object with a special tag. The easiest way is to use the create function in the driving control tab. We get a short straight line where we can add a speed point to tell the car how fast to drive. That's all to let the car drive. The simulation is started by running the animation. The performance is quite bad since it is a high poly car and the recording app is running in the background. Maybe we can improve the performance by filtering polygon objects. Yes, looks better. It's time to enlarge the animation range. When the car reaches the end of the route, it will brake and stop unless it finds another route to continue. The route can be edited like any spline object. So let's add some points. Smoothing the curves. Now we have to add some more speed points. Each point can be moved along the spline using the percentual sliders. And can be set to different speed values. The car will try to achieve these values if possible, of course. Let's drive. Oops, 100 kph is way too fast to get this curve. As you can see, the car won't drive on the line if it was a path animation. It can only drive within the physical limits. So we have to adjust our speed points in a way the car is able to drive. I add further points here to keep the speed of 50 kph. Let's see. It still accelerates much here in the curve. So there is a bit of fine-tuning to do to make the car drive as desired. Before working on any settings, we have to rewind the animation to set the simulation to the edit mode. Let's switch on the pulleys again. Now we need some info of this car to adjust the main parameters. Let's take a look at the vendor's website. I found this datasheet of the E-Class E-State on the German Mercedes-Benz site. You can select an engine. I don't like diesel, so I choose the E250. Here you see some values that we can take for our settings. So let's check the car's parameters step by step. In the Generals tab, we can make general simulation settings, like selecting the start position of the car. You can choose between the start of the first route, the position of the first command object, I'll treat this topic later, and a custom position that can be any coordinates you want. On the File tab you can save and load your setups, so you could build a library of typical setups that you can use as basis for new cars. On the Geometry tab you find the sizes and positions of the car components. The Create Setup function has already adjusted the values to the dimensions of our car model, so we don't need to do anything here. On the Dynamics tab are some parameters that we hopefully find in our datasheet. So let's start with the weight of the car. Let's see if we can find some values. Here is the gross vehicle weight and here is the curb weight that we need. 1720. This is the weight of the whole car. So we have to split it into the main components. I really don't know the weight of the wheels, so I leave the values as it is. Same for the engine. I think 200 kilograms is a realistic value. So in the end, the body's weight should be about 1400 kilograms. Next is the drag coefficient. The default value is fine for almost all modern passenger cars, but maybe we can find an exact value. Okay, here we have it. 0.29, that's not that difference. It's hard to find values for the brake torques. The default values should work for a normal car. If you have a race car or maybe a heavy truck, you may have to increase these values. As a rule, the front brakes should be stronger than the rear ones and be much stronger than the engine power. The tire parameters define the stiffness of the tires when cornering and accelerating or braking. So these values influence the grip of the car. The higher the values, the more grip. Lower these values if you want your car skidding and sliding. Now we come to the powertrain, the drive of the car. You can select between rear-wheel drive, front-wheel drive and four-wheel drive. Let's take a look at the datasheet. The engine power is defined by a torque curve, giving the torque in relation to the engine speed, meaning the revolutions per minute. This is the important parameter describing the power of acceleration. Here we find 350 Newton meters between 1200 and 4000 revolutions per minute. So first we enter this maximum torque and then we adjust the curve in a way that the maximum torque is available within the given engine speed range. This kind of shape can be seen for almost all modern cars. Old engines have a much smaller range for the maximum power. As a basis for the gear shifting range, you can inherit this range. So the gear will be shifted up if the RPM exceeds the maximum value and shifted down if the RPM is getting lower than the minimum value. If you want to achieve more gear shiftings, you can make this range smaller. So let's adjust the gearbox. In the datasheet, we find the gear ratio for this automatic transmission. This car has 9 gears. Okay, let's go. First I set the number of gears to 9. Now we can copy the ratio values from the datasheet. And finally the reverse gear. It's recommended to make short tests after making such essential modifications. For a better performance, I switch off polygons again. Okay, just a quick check whether the values work. On the chassis tab we can work on the suspension. It's very difficult to find concrete values for a specific car. So let's see how the car behaves with the default settings. I create a camera and place it into the body, so we can go with the car. Let's take a look at the chassis from outside. I think the suspension is a bit too soft. So I make it a bit stiffer. Both values are set simultaneous because the front-rear symmetry is activated on the General tab. We can also increase the anti-roll bar spring rate a bit. The anti-roll bar is used to minimize the rolling of the car body in curves. You will find more info on this topic on Wikipedia and YouTube. The car looks more stable now. It doesn't roll that much in the curve. Okay. The car is still in simulation mode, so we have to rewind to get editing back enabled. The camber angle for front and rear wheels is usually used for race cars or at least sports cars. You won't apply it to a normal passenger car. But let me quickly show you what it does. If you set a positive value, you'll get this kind of alignment of the wheels that increases the stability in curves. The caster angle defines the alignment of the steering axis. Cars usually don't have a 100% upright steering axis. The steering axis is displayed here as a green line. To show you the effect, I set this value to, say, 10 degrees. Now we need a closer look on the front wheel. I want the car standing still, so I delete our root and create a command object instead. A command object is like a switch on the floor. When the car touches this switch, certain actions can be executed. In this case, I want the car to steer to the maximum angle. Starting the animation, and the wheels are turning. As you can see, the axis is a bit tilted, just like with a real car. I set the caster back to the default value. With the steering lock, you set the maximum turning angle. And the steering rate defines how fast the car, or better say the driver, is able to turn the steering wheel. You will set this value very high for race cars, because a race car has a direct steering transmission. For a classic car without power-assisted steering, you will set a low value, because the steering wheel has to be rotated much more. New in Drive 1.8 is the rear axle steering. For example, Porsche and Mercedes provide this feature for their sports cars. This feature exceeds our Quickstart tutorial. Please refer the manual and take a look at our Mercedes AMG GT Roadster animation. So, the car settings are completed now. Let's get back to the driving control tab. I've already shown you how to create driving routes and how to create command objects that can be used to additionally send driving commands to the car. In the ground section, we can assign different ground objects, unless you want the car always drive on the zero plane. Also here, the best way is to use the create function. This will create a group object with an example polygon object ground already fitted with a ground tag. You may insert here further polygon objects. The group is also automatically assigned to the car. Here we see the example ground object that we can use for the quick tests. So let's start the animation. There is no root anymore. As an alternative to a root, we can also send a throttle command to the car. So we just need to change the command of our command object. We don't want steering, but acceleration. I set the strength to maximum to get full throttle. Let's see what happens. Looks good so far. Areas where no ground object is present, the zero plane is used, respective the base level that you can define here in the ground section. For a better performance in the editor view, I make the car body invisible. There are also some parametric objects supported, for example the landscape object. I create a landscape with smooth slopes. The object is placed here under the ground object group and the ground tag is attached, that we can take from the example object. A quick test with the onboard camera. The car is jumping a bit because it has quite stiff suspension and drives pretty fast. It's not an off-road car. Maybe better reducing the acceleration. Okay, so far so good. Finally, there is an alternative to using ground objects. You can use a sweep NURBS object to project a road profile along your root spline. So I delete the entire ground objects group and again create a route. We also don't need this command object. Just a simple root spline with a curve. And now I create a simple road profile. It's just a simple line defining the width. Now the sweep object that we move under the root objects group and assign the two splines. The root tag has to be moved to the sweep object. That's very important. Now I can shift the points of the route to get different height levels. If the sweep NURBS doesn't produce a good looking road, you can try the Fit Sweep NURBS settings function that optimizes the sweep NURBS object settings. In this case it wasn't necessary, but when using a rail spline it's a convenient function. Again, we need some speed points to make the car drive. Usually you need at least 2 speed points. One in front of the car to tell it the desired target speed and one at the end. The car always tries to achieve the speed of the speed points ahead in the moment it is passed. So let's see. Okay. Maybe it can drive the curve a bit faster. No, it cannot. Sweep NURBS are the best choice if you want a steep curve. So we need a rail spline to control the banking of the road. I simply copy the root spline and scale it a bit down to get the line of the inner radius. Now shifting the points of the curve a bit down. Move it back under the sweep NURBS. Okay, looks like a pretty steep curve. Unfortunately, it doesn't look good here at the beginning, so I have to move the points a bit away from the root. Let's make another test drive. Okay, that looks good. When the car drives as you want, you should convert the simulation to a regular keyframe animation, especially if you want to render in a network or a render farm. This can easily be done using the record function in the simulation object. Just set the time for start and stop and uncheck output data you don't need to reduce the number of tracks and keys. Now click on record. You can follow the progress with a time pointer. And you'll get usual animation tracks. A further advantage is that motion blur will work better with regular keyframes. You can go back to the simulation at any time by simply deleting the tracks with the delete tracks function. If you want to render on a render farm or on machines where Drive is not installed, you can completely remove the plugin from the project, so that renderers won't output missing plugin errors. Certainly, you should then save the project with a new name, because that step cannot be undone. This is the end of the Drive Quickstart tutorial. I hope it helps you to get started with Drive a bit easier. But I recommend to take a look at the manual. There are a lot of functions that I couldn't show here in this video. Thanks for watching.